ways. Okay. That's one way. Okay. One more. Twosies. All right. This is so hard.
Oh, hey, girl, what you doing?
Counting the different ways.
What'd you get?
377.
Oh, that's what I got. All right.
Great.
Hey, where are you going now?
Well, what if we can take 3 flights?
I did it this morning. It's 17:05.
Oh, thank goodness.
I did it before breakfast, not to flex.
Okay, we're going to look at an answer for one of my favorite problems. I like this problem a lot just because while the answer doesn't seem super nice, 377 ways, the pattern that comes up when you explore it is super interesting, super familiar, and really, really pretty cool. So most people, when they start solving this, will just start brute forcing their way with 13 steps immediately, and they'll say, well, let's say I take all 1 steps, and so that's 1, 4, 5, 6, 7, 8, 9, 10, 12, 13. All 13 steps, 1 stair at a time. There is only one way of doing that, so I'm okay just kind of moving on to the next one. Let's say, though, I put 1 2-step in. Well, that leaves 11 more steps, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1 step. If I take 2 at a time and then 11, that will get me up to the top at 13. I could put that 2-step anywhere along the process, so I could take 1 step and then 2-step, 1, and then finish the rest with 1s. And I can do that all the way until that 2-step gets to the very top. I don't want to write that out. I'm just going to quickly go. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 ways to do that, to do it with exactly 1 2-step. The next thing would be to throw a second 2-step in there. And that would look, maybe I'd put it here, 2, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. That would make 13. Then I can move that 2-step kind of like to the next spot and count it. The problem is it's not just going to be like 9 more or 10 more of those, because I ultimately can move this second 2-step. So really what we want is to kind of find a more efficient way rather than having to list and count every single way. And so that's what we're going to do on the next slide. We'll kind of break it down into a common problem-solving strategy that you, if you don't do already, should very much get in the habit of doing. That is breaking things down into a simpler case. Okay, breaking things into a simpler case. I don't want to tackle a 13-step problem all at that one time. That's too much for me to handle. I want to see if there are any patterns that arise when I go smaller cases. So let's just start with the simplest case possible. What if I have a staircase that is 1 step? Blech. 1 step. Okay, that is a single step. Well, how many ways can you climb that? Pretty sure you can only do it 1 way, which is by taking 1 stair at a time. So for 1 step, there is 1 way to climb it. Let's go up a level and go 2 steps. Well, I could take a 2-step by doing 1, 1, or I could take a 2-step by doing 2. Right? I could take 2 singles, or I could take 2, or I could just take a double step. Which leaves me, that's 2 ways. Let's look at 3 steps. I could do that by going all 1s, 1, 1, 1. I could go and take a 2-step first and then finish it with a 1, or I could go 1 step first and then 2, leaving me with 3 ways. Now, do you see a pattern arising here? Okay, anyone want to bet that 4 steps would be 4 ways? Let's look. For four steps, I could go 1, 1, 1, 1. I could start with the 2 and finish it with 2 1s. I could put that 2-step anywhere, so I could start with it, put it in the middle, or end with it. Or I could do all 4 steps in 2 steps, which means it is not 4 ways. It's actually 5 ways. Okay, so we have kind of an interesting deviation. Our pattern kind of goes 1, 2, 3, 5. Let's see what happens when we keep going. Let's try it with a 5-step staircase. I could do that all as 1, 1, 1, 1, 1. I could start with a 2 and put that 2-step anywhere. I could take 2 2-steps and a 1, which if you see, that really is just let me put any sort of orientation of 2, 2, and 1 together. So it could go 2, 1, 2, or 1, 2, 2. That exhausts all of my possibilities, and you see that there are 8 ways. Okay, so let's look at what we have. We know that this pattern starts with a 1 way to do 1 step, 2 ways to do 2 steps, 3 ways to do 3 steps, 5 ways to do 4 steps, 8 ways to do 5 steps. Maybe just for fun, let's do 6 steps. And we can do that 1, 2, 3, 4, 5, 6. We could put a 2 in there. So 2, 1, 1, 1, 1, 2, 1, 1, 1. Really, we see that there are, how many ways to put that? There's 1, 2, 3, 4, 5 spots. Put the 2, so there's 5 there. We can do 2 2s, so 2, 2, 1, 1. And then we can just distribute those 2, 1, 2, 1, 2, 1, 1, 2, 1, 2, 2, 1, 1, 2, 1, 2, 1, 1, 2, 2. And then finally, we can take everything in 2 steps, which gives me 1 plus 5 plus 6 plus 1, which looks like it is 13 ways. So the next step in this pattern is a 13. And at this point, I want you to really focus on this and see how do I get the next number based on this pattern. Pause and think about it if you'd like, or meet me on the next slide in a few seconds. Okay, just a reminder, we are exploring this 1, 2, 3, 5, 8, 13 pattern that we just popped up. And if you haven't had a chance to think about it, pause and think about what the next number might be. If you have, you are correct in guessing 21. And that's because if you notice, if I take 1 and 2, add them together, I get 3. If I take 2 and 3, add them together, I get 5. And likewise, 3 and 5 added together to make 8. We have stumbled, surprisingly, upon this Fibonacci sequence. Now, first of all, you might notice something's missing. Fibonacci usually starts with another 1 in front. And if you'll recall, this first one we started with was a 1-stair problem. And there's 1 way to climb 1 stair. If you go back a step, how many ways are there to climb 0 stairs? That's only 1 way in that you don't climb 0 stairs. Maybe it's a technicality, but that's how I'm viewing it. So in order to find the 13th, the answer to the 13th stair problem, all we need to do is find the 13th term in our sequence starting at this 1. So 1, 2, 3, 4, 5, 6, 7. We need to find term 8, 9, 10, 11, 12, 13. And I will let you just start adding those together. Ultimately, when you get there, you will get to 377 stairs. Oh, sorry, 377 ways to climb the staircase. Now, that's great, but what's even better is the Fibonacci sequence being generated by taking two terms, 1 and 2, adding them together to get 3, and then 2 plus 3, adding them together to get 5. What I can actually see in this stair problem how generating 3 comes from the solution to stairs for one stair and the solution for 2 stairs. I can actually see with the stairs how my solution for 5 comes from my solution for 2 and my solution for 3. So pause and think about it yourself. What I want you to do is to be able to see how Fibonacci, this whole like adding consecutive terms up idea, how that can play out in the stairs. So on the next slide, I'll go into a description of that, but I want you to mess around with it first. Okay, we're going to look at how Fibonacci can actually be seen in this staircase problem. And in order to do that, what I want to do is start at a 3-step staircase. So 1, 2, 3 steps. Now, what I want you to notice is there are just only 2 ways you can start climbing 3 steps. Okay, you can either start with 1 step, or you can start with 2 steps. Okay, only 2 ways to start. If you start with 1 step, how many stairs do you have left? Well, you have 2 stairs left. Okay, we know how many ways it takes to climb 2 stairs. Okay, there's only 2 ways to climb 2 stairs. Okay, so if we take 1 step, if our first step is 1, then there are 2 ways. Okay, the other option is to take 2 steps first, which leaves us with 1 stair remaining. Okay, and we know that there's only 1 way to climb 1 step. So if the first step is 2, then there's only 1 way, which if you look at this, you have 2 ways to do it, plus 1 additional way gives you a total of 3 ways. And you'll see we used the term right before and the term, and 2 terms ago to answer. So let's extend this. Let's say we climb 4 steps. Well, there's only 2 ways to start. You can start with 1 step, or you can start with 2 steps. If we start with 1 step, that leaves us with 3 steps left, which we know how many ways there are to climb 3 steps. There's just 3 ways. If we take 2 steps first, we are left with 2 steps, and we know that there are only 2 ways to climb 2 steps, which gives us a total of 5 ways. And you see right here, we have the term right before plus 2 terms ago. 3 plus 2 makes 5. Let's fast forward to our 13-step answer. Well, there are only 2 ways to start climbing 13 steps. You can start with 1, or you can start with a 2 step. If we start with 1 step, that means that there are 12 more steps. And by this time, hopefully, we have been able to generate however many ways. However many ways are in that, I don't know, A ways. Okay, just some unknown amount of ways for me right now because I don't have the 12th term in our sequence memorized. The other thing you could do is start with 2 steps. 1, 2, leaving you with 11 more steps. And you know that there are a certain amount of ways to get that. So for 13 steps, you see that you take the number right before, add it to this, the term twice before, and you get your total number of ways, which is 377 ways. You can extend that. Really great little application or surprising thing about the Fibonacci is that it pops up this way. The last thing is, what would this look like if you were to do 1, 2, or 3 steps at a time? And we'll do that on the next slide. I'm not going to give you the answer, but we're going to get started. Okay, to get you started on this one, there are, to climb 13 steps, instead of just 2 options to start, I could start with 1 step, I could start with 2 steps, or in this case, now I can start with 3 steps. So if I start with 1, I have 12 steps left. And hopefully I know the answer for 12 steps. If I have 2 steps, then you'll see I have 11 steps left. And if I have 3 steps as my first option, then I have 10 steps left. And you'll see that really, if it just becomes the term before, so if I'm looking for 13 stairs, it just becomes the answer for n minus 1 plus the answer for n minus 2 plus the answer for n minus 3. It's essentially the same Fibonacci sequence pattern, but instead of taking the 2 previous terms, you take the 3 previous terms. And the answer for this one, if you work it all out to the 13th step, is 1,705 ways. And you can challenge Mr. Heatonbush on whether or not he actually did do all of those steps before breakfast. My hunch is it took him at least till lunch, because that's a lot of step climbing. Okay, good job, people. Thanks for staying with us. Look forward to some more fun and interesting problems in the future. Again, remember the purpose of this is to keep us engaged and thinking mathematically, and hopefully we're going to have some fun along the way. So until next time, have a good couple days and stay safe. Keep your hands washed. Don't see anybody. Don't talk to anybody in person. Hide yourselves. Hide your kids. Hide your wives. Take care.